Hello, my name is Alexandra Manueli. I'm the managing editor for GFSR, and today I'll be speaking with Dr. Mathew Moore. Mathew is an assistant professor of food science at UMass Amherst, and today we're going to be speaking about something that is absolutely crucial to keeping food safe, which is pathogen detection. Mathew and his team have been working on some very interesting projects, and I'm really excited to dive into those with him. So let's just get right into it. Thank you so much for speaking with me today, Mathew.
No, thank you very much for the opportunity.
Awesome. Okay, so I hear that your lab is developing tools to aid in sanitation regimes and training. So first, in your opinion, can you explain why proper sanitation regimes are so crucial to good food safety?
Yeah, absolutely. I mean, I think sanitation and training it's maybe a little bit overlooked and definitely something that's extremely crucial to food safety. And honestly, I kind of have to give a shout out actually to our one of our extension associate professors here in this department, Amanda Kinchua, who actually does a lot of the boots on the ground sort of training and puts on workshops related to sanitation. But I mean, I think it kind of goes without saying that that's certainly something that almost any sort of quality assurance or food safety professional is going to have to consider if they're producing food in almost any capacity. And one of the things that our lab in particular is interested in is trying to come up with some real visual tools that you can use to sort of aid training and sanitation. Usually having good sanitation practices in the food production environment is actually usually the byproduct or indicator of a really strong food safety culture. And so one of the things that our lab is interested in is trying to come up with tools to sort of aid training related to maintaining those good sanitation practices.
Why do you think that this is kind of a lesser discussed topic in the world of food safety, even though it's so crucial?
Yeah, that's a great question. Honestly, I don't actually really know why it isn't. It's something that's very, very important, and I think that's something that maybe greedily we would say maybe there aren't necessarily as easy tools in terms of training and actually reinforcing positive food safety sanitation practices in terms of behavior. And so I think that might be it. It's maybe something that you really have to get in the habit of and really have a strong culture in whatever food production environment you're in. And so that's maybe one thing that hopefully the tools that we're developing will address.
Yeah, absolutely. I agree with you. Why don't you get into explaining one or two of those tools that you're developing and how you think they're going to enhance our food safety?
Yeah, cool. So one of the things that and this is in obviously in collaboration with Amanda as well as some other really awesome professors in our department. We're trying to develop basically an alternative to something called GlowGerm. So GlowGerm is kind of a fluorescent sort of visual surrogate that you can use. I don't know, you maybe have been in like sort of hand washing demonstrations where it's basically, it comes in multiple forms, but it's basically a microplastic resin that contains melamine that, when you shine a specific UV light on it, it'll glow green. So you can rub it on somebody's hands and then see if they've actually washed their hand properly, or you can demonstrate trying to transfer, hey, here's what happens if you don't wash your hands. One of the challenges though with a product like that is that, melamine is a known food adulterant in a number of cases, and it's also a microplastic resin. So the surface properties and transfer behavior and adhesion behavior of that may not necessarily be reflective of what you're trying to mimic. In this case, a bacterial cell surface or a virus surface. And so one of the things that our lab is trying to do is to try to design food grade fluorescent compounds that more accurately mimic the surface properties of a bacterial cell membrane surface or a viral surface, using a partnership actually with one of the other really awesome chemists in our department, Dr. Julian Clements. And so that's sort of the crux of that is that ultimately we'll hopefully have a tool that has all food grade components that actually does mimic the surface and transfer properties of a pathogen or a set of organisms of interest. That also actually consequently, even though you wouldn't really use it for disinfection, actually some of the naturally fluorescent food grade compounds can have some degree of antimicrobial property too. So you can imagine maybe the power of something where you actually have a visual indicator that you confirm that, you properly washed your hands. But, like, let's say you put it on your hands, then you wash it and then put it under a light just to confirm that, you wash properly. That product would also additionally kill microbes on your hands as well, in addition to being food grade.
That's very cool, and I can see how extremely useful that would be in so many settings. So I can't wait to see that available to us.
Yeah, no, we're really excited about the project, and we're still applying for grants still to try and take it further.
Awesome, wonderful. Okay, so I know your lab is also working on novel portable pathogen detection. Why is this so important to the future of ensuring safe food?
Yeah, I mean, it can depend specifically on what pathogens you're dealing with, but it's absolutely crucial to be able to not only detect pathogens, but just have really good detection assays in general, be it for indicators or pathogens that have ideally a short turnaround time, and ideally not requiring too much either pre-enrichment steps or sample preparation prior to detection. And so this is something that our lab is also really interested in, because we primarily actually study foodborne viruses. There's a unique challenge in detecting viruses in that, unlike bacteria, it's not as easy to create an enrichment step. You can't necessarily just take media and throw it in an incubator and get what you're trying to detect to grow. So with viruses, you're basically trying to identify or concentrate needles from a haystack where you have this large complex food sample, when you're trying to specifically try and pull out just the viruses, so that downstream you can apply detection techniques as well. So this is something that our lab is very interested in, is how do you get these very, very small viruses, of which there may not be very many, contaminating a food or an environmental sample and concentrating them. And then the other aspect of our lab is trying to come up with portable detection techniques that are very rapid, and that also don't necessarily require a heavy equipment footprint. So we have a number of projects going on that would enable sort of detection techniques where you don't necessarily, in some cases, even require an electrical grid. One of the other things as well that we're interested in detection is maybe more in the identifying outbreaks aspect of being able to not only detect portably, but to also subtype. So traditionally, the gold standard for subtyping is whole genome sequencing. That said, for whole genome sequencing, that can take a matter of days, and it requires shipping something to a central lab. We actually have technology that we're working on now that was actually partially funded by a grant by the USDA National Institute of Food and Agriculture. That's a technology that's traditionally been applied in using more clinical biomarker targets, but actually has the potential to not only detect, but potentially subtype. And so it's one that we're working on right now in terms of being able to detect and subtype foodborne viruses as well as salmonella, both of which we picked as sort of pathogens of interest because they're very diverse. So yeah.
That's very exciting. And I can see how that would have application across the supply chain. Where do you think that tool will be of most use for preventing foodborne illness outbreaks?
Yeah, well, so if ideally, if you have subtyping ability, it'll enable you to identify outbreaks more quickly, maybe from a more public epidemiological standpoint, so you can stop it, especially when you're dealing with something that's as transmissible as foodborne viruses. That being able to stop it earlier rather than later is really key to stopping the spread. Especially with the viruses that we deal with, there's foodborne transmission, but there's also a large person-to-person component as well as environmental. So yeah, it would depend on the pathogen itself as to where being able to detect it would be the most effective. But at least in the case of viruses, it's usually at the point of preparation, because most contamination of this with noroviruses is food handler associated or person-to-person setting.
Awesome. So can you explain what pathogen inactivation is? I know you're also working on this. You guys are working on so much right now. you can only skim the surface really in this conversation, but I mean, there's so much that I think that our audience is going to be interested in hearing about. So this is another one that I cherry picked for this conversation: pathogen inactivation and why this work is so essential again to food safety.
Yeah, no, it's a great question. Again, with us being more in the virus kind of space in terms of our interest, one of the challenges traditionally with noroviruses as well as some other foodborne viruses is that they're not necessarily as easy to kill. So with pathogen inactivation, normally you think of a disinfectant, or if it's a heat process, heat does work pretty well against these viruses, but you're sort of seeing a lot of foodborne outbreaks associated with foods that don't traditionally have a cooking or heat step, and that holds true for these viruses as well. And so traditionally, one of the challenges has been, a lot of the traditional inactivation agents that people will use they don't give you necessarily the kill with viruses that you would necessarily like, at least at the recommended contact times. Um, and so this is another thing that our lab is very interested in is, okay, you have these viruses that remarkably, even though they're very, very small and they seemingly have a very simple sort of structure, are extremely difficult to inactivate. And so one of the things that we're concerned about is just trying to come up with ways to better deliver sort of inactivation agents to kill these viruses. Because really now bleach is largely regarded as the most effective for them, and bleach at high levels. But as you may understand, you can't necessarily apply bleach to a lot of surfaces. There may be restrictions in terms of its utilization.
Wow. You've given us so much to think about, and I'm sure that you're going to have so much to share with us if we come back to this conversation in 6 months' time. Mathew, thank you so much for chatting with me